Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. As you step on inside, we are in the Big Ideas Math Integrated Math 2 textbook on section 2.5, factoring x squared plus bx plus c. You'll know a lot more about what that means later. To me, I call it the basic factoring of quadratic trinomials. Where the a equals 1. We'll get into what that is once again. Not as basic as greatest common factors, and in fact, I haven't looked ahead, so I'm not sure. I hope they do greatest common factors with this stuff. You'll see what I mean when I actually start talking about it. But this is the start of really the heavier quadratic factoring or polynomial factoring in IM2, where I think you'll get this section pretty well. It's the one after that 2.6 that I even wonder how I want to record it to assist you guys and not make it the longest video ever or show all these different ways and stuff like that. But section 2.5 on this basic factoring, I think you'll grasp pretty well, especially if you know foiling, and yeah, we'll pick up on it. Now, the zero product property should be coming into play. I do believe, and I hope that they're going to be solving equations by factoring with quadratics, and in the same manner that if you create a product of two things, I should just save it for when they show it. But what I wanted to say about this is that teachers teach this stuff differently. The book might teach it differently than a teacher does, even than myself. I sometimes have trepidation going into these and wondering, how are they going to talk about it, and how can I still be comfortable talking about it my way of going about it? Because a lot of the factoring that I do is more so mental. You can write things out, but it's not this process where there are different methods and things like that. You still get to the same answer, and what your teacher teaches is probably what you should follow. I'm just going to offer my little version. I'm going to show what the book shows, whatever it is, and I'll say where I defer, or if I stay the same. I'm actually not sure yet. So let's go ahead and take a look at what they do within the individual sections. We have about 50 homework problems to do after this and see what's going on. I might have to clear my throat, though. Give me 1 sec before we actually start. Okay, so we're going to go ahead and take a look at this. What you will learn to factor x squared plus bx plus c. If you look at what that really says is it's a quadratic trinomial. The highest degree is 2. Then we have a linear term and a constant. B and c are really just any number. But the fact is in x squared plus bx plus c, what would normally have an a right there, it's just 1. So this is a lot easier to factor. This process that we take has a lot less things going on with it than if there is an a value that's there that we can't factor into just a 1. So anyway, we're going to do that and use factoring to solve real life problems. It seems like that's always a thing in one of these, and we hit word problems and we'll get to them. Okay, let's see what they say about this. Writing a polynomial as a product of factors is called factoring, and the greatest common factor thing applied to that as well. To factor x squared plus bx plus c as x plus p times x plus q, you need to find p and q such that p plus q equals b and p times q equals c. So I'll say this. They're going right into the deep end with you on what it is that you do without getting into the why, which is okay. It's fine. But you might have read that and say, what the heck are they talking about? Well, if you kind of look at one I guess it's deep end with floaties. What they're showing you here is if you distributed a linear binomial set, a 2x2 right here, what you often get, what happens is you get that first, outside, inside, last, but the outer and inner terms combine to become a single term. And I know it's weird to see them as p's and q's, and what is p plus q? I'd rather look at 5 plus 2, but it becomes a single term. So what happens is you have your quadratic term, your constant term, and your linear term, which is a combination of p plus q. X squared plus p plus q, x plus p times q. What they're telling you, however, is that the p and the q values, x is multiplying with it. 1x. 1x times q is qx. 1x times p is px. And those numbers didn't change in these terms. What you see in the factorization is also what you see in the terms themselves. And what they're telling you is that if you find the sum of p and q, you get b. B is the sum of your p and q that exist in your factorization. Now, we are not distributing. Our goal is to go this way. Our goal is to take an x squared plus bx plus c and factor it into an x plus p times x plus q. And what I just said is that p plus q, those two numbers, will add to your linear coefficient. What also happens is P multiplies with Q in the end, and that seems to match your constant term. So P times Q is C, and that's what we're getting. I mean, they're just literally using the letters P and Q, and we just jump into it with that. That's totally fine. I don't know how much I'm going to mention the letters P and Q. What I do want to mention, though, is, you might run into what are called diamond problems. I know I do them for my students in particular, where if you draw a diamond or just an X itself, it doesn't matter how it works. The values on the left and right, we multiply to become the top value, and then we add to become the bottom value. So if you have two values and we say what two numbers multiply to this and add to this, that's something that we've practiced a lot before, and that's what this is. I know I'm walking slowly through this, but this is the very first time we're looking at it. Now, they mentioned this when C is positive. When C is positive, that's your product. When you multiply two numbers and you get a positive result, P and Q have the same sign as B. They really say it very mathy. I'm going to try and say it a different way. When you have a positive product, the two numbers that represent those factors that multiply your product, the two factors must either both be positive or both be negative. Because only a positive times a positive is a positive, and a negative times a negative is a positive. So we see two examples. We see x squared plus 6x plus 5, and your goal is to factor this. Your goal is to create a factorization out of it. And really the end thing that I wanted to talk about with this trinomial is this was two terms. 6x was two terms before. This whole thing was four terms. It was a distribution of a binomial times a binomial. And we can come up with what these are by finding out what two numbers multiply to make 5 and add to make 6. Because when you see this foiling distribution, x times x gives you x squared, great. But x times 5, 5x, plus 1 times x, 1x, gives you 6x. And 1 times 5 gives you 5. The 1 plus 5 is that 6, and the 1 times 5 is the 5. And that's what we're getting at. But what they also want to show you is that in x squared minus 6x plus 5, the only difference is the linear coefficient changes from positive to negative, but the product is still positive because negative 1 times negative 5 is still positive 5, even though when you add them, you get a negative coefficient. The only difference between these two that look like this is the minuses versus the pluses. The product is still positive when you have that. So that's just that scenario. So now they're showing a case, and I mean, this case is there. I wonder how long I have to live in these examples because I do want to get to the problem set. But when B and C are both positive, then that must mean that, factoring x squared plus bx plus c, that must mean that all your things are positive. It's an x plus this times x plus that automatically. There's positive sum, positive product. So factor x squared, hold on, let me fix something. Factor x squared plus 10x plus 16. So they say, notice that B is 10 and C is 16. I got something that adds to 10 and something that multiplies to 16. Because C is positive and because B is positive, our sum and factors must both be positive. So what they're going to have you do, and this sounds like something I would do as well, list your factors of 16. 16 can be 1 times 16, 2 times 8, and 4 times 4. Now I might write this differently when it comes to what it is that we're going to do, but 1 times 16, 2 times 8, 4 times 4. There are a lot less integers that multiply to 16 than there are integers that add to 10. Think about the ones that add to 10. 0 plus 10, 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6, 5 plus 5. And then obviously the reverse. Notice I never said 16 times 1, 8 times 2. Once you've listed them out, you're good to go. But what we're going to do, it's a little bit of trial and error. It's one of the only guess and check methods in math that actually even applies to what you do. Otherwise, there are generally other cases to what you do. We guess and check. Does 1 times 16 is 16. I need two numbers, though, that add to make 10. Does 1 plus 16 give me 10? No, 17 does. Does 2 plus 8 give me 10? Yes. Now, before I move forward with that, does 4 plus 4 give me 10? No, that gave me 8. 2 plus 8 gave me 10. 2 times 8 is 16, 2 plus 8 is 10. Those are the two numbers that we were trying to figure out that fit into the factorization of x squared plus 10x plus 16. The 2 and the 8. The values of p and q are 2 and 8. So x squared plus 10x plus 16 factors into x plus 2 times x plus 8. Now, I feel like I could teach this better than, I'm not saying teach it better than the book. I feel like I could teach it better than demonstrating it through the book. So if you feel a little confused right now, I hope that when I'm doing the actual problem sets, it'll make a little bit more sense. I obviously don't want to live in this video for 2 hours, so I want to try and get a little bit farther with it. But the double check, of course, once again, as x times x is x squared. X times 8, 8x, plus 2 times x, 2x, gives me 10x, and 2 times 8 gives me 16. But that's the pattern, right? That's the pattern. Now, they have us try and check a couple of these. I'm not going to bother because I'll do them in the problem sets, but let's keep moving forward and look at the conditions they're talking about. And this is where I think I'm going to speed up a little bit more. They're really showing you all these conditions right now, and it's important. It really is, and I actually make good use of them. They're trying to avoid you testing more things than you have to, and that's exactly what I would do. So they're saying, what if B is negative and C is positive? We already talked about this. Both of the numbers would then be negative in this case. We talked about how both would either have to be positive or negative with a positive product. Well, when the sum is positive, then both your numbers are positive. When the sum is negative, both the numbers are negative. So x squared minus 8x plus 12. We're going to test products of 12, but both of those numbers will have to be negative. So what are your products of 12, or factors of 12, as I should say? Negative 1 times negative 12, negative 2 times negative 6, and negative 3 times negative 4. You might say, what about 1 times 12, 2 times 6, and 3 times 4? None of those will add to negative results. Only the negative versions of them will. So negative 1 minus 12 is negative 13. Negative 2 minus 6 is negative 8. That one seems to work out. You can stop at that point and just move on. Negative 2 and negative 6 are your two values that will also spit into your factorization because when distributed out, they multiply to become that bit. So this is very special with 1x squared when we do this. Here's our double check to use the FOIL method and see that that's exactly what you get. But that's what you're doing. Find your products of your C, find your factors of your product, and then go ahead and see which ones add to become B. So let's keep going. What if C is negative? What if you have a negative product? How do you multiply two numbers and get a negative result? One's positive, one's negative. Now, they're probably going to talk about some of the things here, but the thing is B could be positive or negative, all depending on this, and they'll show both cases, I'm sure. So in this case, I kind of mentioned it, but you notice this x squared minus 4x minus 5. 5 is this time negative. That comes from either 1 times negative 5 or 5 times negative 1. Now, your goal is to find the one that gets you a negative 4 sum. In that case, that's 1 minus 5. Instead of 5 minus 1, right? So x plus 1 times x minus 5, 1 times negative 5 is negative 5, 1 minus 5 is negative 4. That's where that would come into play like that. All right, so factoring when this is negative, let's look at x squared plus 4x minus 21. So I don't know if they get into the talk. I'm about to talk about it. They don't really. So hold on, let me move forward one. Okay, they don't really talk about this next thing. Okay, very interesting. I separate the condition between when B is positive versus when B is negative. We have a negative product, so we know one's positive and one's negative. Notice that this one has a positive sum. How can you have two numbers subtract? Because I'm adding a positive with a negative. That's subtraction. How can I have two numbers subtract but keep a positive result? The positive number has to be bigger. The one that I'm subtracting from, this, I have to do big minus small, basically. So when I test my factors of 21, negative 21, which aren't too many, I'll show you how I would do it. Factors of 21, and I forget how I do a little box. That part doesn't really matter. But I got 21 times 1, and I have 7 times 3. Okay. Now, how about factors of negative 21? They show you all the four different ones. Negative 21 times 1, negative 1 times 21, negative 7 times 3, negative 3 times 7. What if we cut that amount in half? Which that doesn't sound like very many, but this list could get large depending on your factors. Try factors of 64. Right, there are a bunch of them. But anyway, what would I do here? I'm going to do big minus small. My number is 4, positive 4. 1 minus 21 and 3 minus 7 aren't going to get me a positive 4. Only these have the possibility of it. 21 minus 1 is 20. That's clearly not it. 7 minus 3 is 4. That clearly is it. So 7 and negative 3 are those two values that go into there. Now they show that. They get that answer. But they tried this one before and this one before that had no chance of ever getting it because they were negative. I'm really surprised the book didn't cover that, especially when they really, and I am poo-pooing on the book this time, especially when they consider the cases of a positive product and when you have a positive versus negative sum. Anyway, I'm going to move forward because I want to get into this. So negative 3 and 7 are those two values, so we get x minus 3 times x plus 7 as the thing. And this is, it's not even 15 minutes in. I was going to say this is my largest lecture by far, but I guess not. Now, I'll tell you what. I'm not going to teach these ones. I'm just going to factor these whip fast for you in case you want to try them later. So this is going to be some of them. And I'm going to do it while talking about something else. You know what I don't see in this that I really wanted to see was greatest common factors, GCFs. Maybe they hit it on the next set. I have no idea. Perhaps. But x plus 15, x minus, y, I'm sorry. But, one of the things is, as you just came off of greatest common factors, is that it's really important that you note that you always look for greatest common factors first. Before you do any of the stuff we're doing for what two numbers multiply to this and add to this, always get greatest common factors first, because the end result of what we factor is we must factor completely. We must factor completely, and that includes greatest common factors as well. So that's what these all factor to. Right here, if you want to try those later, understand why those come into play. I hope that that's making a little bit of sense. I'm just going to leave them there, but I am going to move on. Let's look at word problems. Real life problems. A farmer plants a rectangular pumpkin patch in the northeast corner of a square plot. Looks like this guy right here. Square plot of land. The area of the pumpkin patch is 600 square meters. Wait, was this was the pumpkin patch, right? What is the area of the square plot of land? So understanding the problem, they're asking for the entire plot of land, given only that this part's 40 and this part's 30. We have some s's involved to kind of explain that away. So we can come up with a representation for what this is in terms of s, and they show it down below. The length of the pumpkin patch is s minus 30 meters, and the width is s minus 40. If this whole thing is s here, and this part's 30, then we take 30 away from that part, and same with here, s minus 40. And that's the plot of land. When you multiply this base with this height, you get 600. Now, I will say this. This example is really important to cover, not because the word problem, because something else that they're talking about. You know how we practiced factoring? We never practiced solving these by factoring and using zero product property. We did it in section 2.4, but we're going to do it again in section 2.5, at least with the area problem, or with the word problem. So here, I need to spend a little bit more time talking about what they're going to do, because it's really important that we talk about this. They're jumping right into this without, I hope I didn't delete a page. They're jumping right into this without it. So sorry, book, I'm going to poo-poo on you guys. You got to have examples using zero product property before when it's not yet set equal to 0. This is a major jump. Not even your last section did this. So big ideas math, I'm talking to you about this. You got to address the example portion. Okay, so what we're going to do is multiply the length times the width and get 600 as the area. So they're showing you that. S minus 30 times S minus 40 equals 600. Great. Does that mean, because what are they asking us to do? Find the side lengths, right? What is the area of the square plot of land? We need to solve for S. Now, I have this times this equals 600. You've solved for factored things before using the zero product property, saying if this times this equals 0, then this equals 0 and this equals 0, and we've learned how to reverse these things. You might say S equals 30 and S equals 40. Well, that's not the case for this problem, because this is not set equal to 0. Now, what could I do? I could subtract 600 from both sides, minus 600, and turn that into 0. Great. Okay, now it's set equal to 0. Now S equals 30 and S equals 40. No, because this is no longer a product anymore. Yeah, I have a product of these two terms, but then I have minus 600 subtracted. Now I have a difference. So I will subtract 600 at some point. I do have to set it equal to 0. But the more important part to do right now is 600's got to combine with something, because I have something factored. I want to distribute it, combine 600 with something, factor it again, so I then create a product when it's set equal to 0. So they start by foiling S squared, S times S, and then they do minus 40S minus 30S. That's the O and I of FOIL. Then negative 30 times negative 40 is 1200. So they FOIL, they multiply, they distribute. Then they subtract 600 from both sides. Minus 600 minus 600. 1200 minus 600 is that. 600 minus 600 is 0. The goal is we've now created a new quadratic trinomial. That wasn't this, but that's this, and hopefully it's factorable. In this case it is. We want to find two numbers that multiply to make 600 and add to make negative 70. Now, as far as that work goes, there are a lot of factors of 600. There's 600 times 1. There's 300 times 2. You know the easy way is of factoring is keep dividing by numbers. Let me show you all the lists, by the way, and how this works. 300 times 2. I shouldn't do it on this problem. It's already done. There's 200 times 3. There's 150 times 4. There's 120 times 5. There's 100 times 6. You can see how I guess I won't do all of them, but the list goes on and on in that way. All the way. Now, there is, eventually you get 60 and 10, and apparently those are the two factors here, or more so, positive product, negative sum. That means both of these would have to be negative. These ones don't add to negative 70, but negative 60 and negative 10 do. There are some in between with 8. 8 is in between as well. There's 20 times 30 and stuff like that. But they factor into s minus 10 times s minus 60. This is set equal to 0. And using the zero product property, s either equals 10 or 60. However, s can't equal 10. Because if you substitute 10 into here, you get 10 minus 40, which is negative 30, and 10 minus 30, which is negative 20. You can't have negative lengths. So s equals 10 actually doesn't apply to this one. It doesn't work out. Only s equals 60, for the sake of this problem, works. Oh, look, they wrote it right here. The diagram shows the side length is more than 40 meters, so a side length of 10 meters does not make sense. Oh, and that too, right? This shows this is 40. How can this only be 10 if the whole thing's 40? So 10 doesn't work, only 60 works. So how do you find the area of this plot of land? We have 60, wait, what do they want? Oh, the square plot of land, 60 by 60. So 60 times 60 is 3,600 square meters. Now the area of the pumpkin patch, you do 60 minus 40 times 60 minus 30, all that stuff. Okay, that was a lot of stuff to talk about with that. One concept summary that they show at the end, and then I got to go to the problems. I guess this lecture is longer than all the other ones. And I wanted to add one more thing with this, at least saying it out loud. X squared plus bx plus c, a quadratic trinomial where your quadratic coefficient is 1. Leading coefficient is 1. That's important for these. When it's not 1, you either find a greatest common factor so that it is 1, or there's more to do. And that's section 2.5 or 2.6. But in this one here, it factors in x plus p times x plus q. Those p's and q's as a product make c. Two numbers, you say what two numbers multiply to make c and add to make b, whatever those numbers are. You find them. But your tips is you start trying to only find ones that are based on the concepts of what if you have a positive product and positive sum? You're only looking for the positive sets. Ignore the negatives. You're never subtracting, never negatives. No. Positive product and negative sum, both of them are negative. Only test those. Negative product. If the sum is positive, here's where I'm talking. First of all, they're opposite signs. One positive, one negative. If the sum is positive, the positive number is bigger. If the sum is negative, the negative number is bigger. And you're going to see me test that way. Okay, we're going to dive into the problem set in a way. We're going to first begin, of course, with the vocabulary and core concept check. Number 1, writing. You are factoring x squared plus 11x minus 26. What do the signs of the terms tell you about the factors? Explain. I'll tell you more than the book's been telling you. Of the factors. Okay. Never mind. I'll tell you the exact same amount. One factor is positive, and the other factor is negative. Now, as far as what I would test, the positive, I'm only going to test the bigger one's positive, and the other factor is negative. This is because a positive number times a negative number equals a negative number. Now, this is all about, I'm probably not explaining enough in this way. We're looking at negative 26. That's the important part. Oh, it says, what are the signs of the terms? Yes, I also want to mention the positive number is bigger. Okay, the positive number is bigger. This is because a positive number times a negative number equals a negative number, and a bigger number minus a smaller number is a positive number. Sorry, a bigger positive number minus a smaller number. Positive number is positive. Okay, I'm running out of room when I do that, so I'm going to say number with a little sign. Okay, so anyway, When I'm referring to C, C is the product portion when you multiply to make the negative, and the positive of this becomes that. Now, does this factor? Yes. I'm not going to do it though. All right, write a trinomial that can be factored as x plus p times x plus q, where p and q are positive. Okay. So what you probably want to do is create something that, well, no, I take it back. You can just multiply. Just take two numbers. Let's take 2 and 5. 2 and 5. So p can be 2, q can be 5, right? 2 times 5 would give you the product here. That would be 10. And 2 plus 5 would give you the sum. That would be 7. So x squared plus 7x plus 10 can factor. Now that would factor into x plus 2 times x plus 5. Okay, that would be that version of that. Okay, guys, that was a lot in the lecture. Again, I go in these cold. I don't know what to expect with them, and I think that there were some parts of the lecture that actually kind of botched what we were talking about with it because they jumped to the word problems, which covered all the parts in solving, and even in the worst ways. We're going to run into them here. If you weren't listening to any of those other parts before, then welcome to this part of the problems where we start from numbers 3. We're going all the way to 51. I'm checking my time. Okay, so let's go ahead and begin with these. We start with factoring the polynomial on numbers 3 through 8. So number 3, we have x squared plus 8x plus 7. I will talk about some of these things like you did hear me in the lecture, which means some of these will go kind of fast. I'm going to start with some of the guess and check kind of mentality of this, but after a while, I think I'm going to have to speed up. Because I can do these fast. Hopefully you can as well. You're going to get to do these fast. X squared plus 8x plus 7, we're trying to find two numbers that multiply to make 7 and add to make 8. Because 7's a prime number, the only set that you can possibly have is 7 and 1. 7 plus 1 equals 8. Therefore, this factors into x plus 7 times x plus 1. That is the result of this. Number 4, z squared plus 10z plus 21. Now, I did make mention, I don't think there are any greatest common factor thing. I'm looking down the list. I don't see anything where we're going to... that's not standard form. Where we're going to have to seek a greatest common factor first. That probably happens in the next section. All right, I want to find some factors of 21. List them factors. And, 21. 21 times 1 and 7 times 3. By the way, what I'm mentioning is this is a positive product and a positive sum. All of these in 3 through 8 actually have that. So we know that we're only testing positives. 21 plus 1 is 22. No. 7 plus 3 is 10. Yes. That's what that'll result to. Z plus 7 times z plus 3. So you can see where outside of listing factors, I don't think I want to do it each time, but I'll say them out loud. Number 5. N squared plus 9n plus 20. I'm trying to find factors of 20 that add to 9. So let's try some. 20 plus 1. Remember, 20 times 1 is 20. So 20 plus 1? No. 10 times 2? No. Excuse me, 10 plus 2? No. 5 plus 4? Yes. 5 times 4 is 20. 5 plus 4 is 9. So 5 and 4, that becomes n plus 5 times n plus 4. Now, there's that diamond method thing that I referred to earlier. Maybe you do your test in that way. Someone's like, oh, you know what? I really need to draw this thing out. I need to feel this. I need two numbers that multiply to make 20 and add to make 9. And you do your tests on the side. That's all good and great. You come up with 5 and 4. You write it down. You lodged it in for sure. You do that. I know a lot of people have those instances like, I need to see it. And I feel you. I don't have to, but I feel what you're going for with that. S squared plus 11s plus 30. Let's factor that. Factors of 30 are 30 and 1. Those don't add to 11. 15 and 2 don't add to 11. 10 plus 3, pretty close. Not quite. 30 doesn't divide by 4. It divides by 5 and you get 6. 5 plus 6 is 11. So you get s plus 6 times s plus 5. Now sometimes you luck out, as in the first thing you try is there. 30 is sometimes that common, besides 10 times 3, obviously. Like 15 times 2 is probably the last one you'd think of. 5 times 6 is one that kind of comes up a lot. Those are both numbers that are less than 12 because, products that multiply to 12 is a very common thing that you see in math. So that's just something that you might run into really fast. H squared plus 11, h plus 18 for number 7. So we're trying to find two numbers that multiply to 18 and add to 11. You have among 18 times 1, or 18 plus 1, and 9 plus 2. That worked. 6 plus 3 is 9. That doesn't work. But once you find it, you can stop. So h plus 9 times h plus 2. Oh, hasn't been asked yet. I don't know how someone can ask. Mr. Robinson, does the order matter for which we write these? No, not for the factors. Just make sure that when you have to do different sign changes, make sure that the appropriate sign is with the appropriate value. You could have written h plus 2 times h plus 9. You're good. Mine just so happens to probably be written with the bigger number first because that's how I'm processing it. When I say that, 18 is 18 times 1, I'm not saying 1 times 18, and I guess that's why. So y squared plus 13y plus 40. 40 might have a few more factors. 40 and 1, 20 and 2, 10 and 4, 8 and 5. 8 plus 5 is 13. So that would work out. Y plus 8 times y plus 5. Okay, those were all positive products and positive sums. This is a good set for just drill and kill. I wish in some way there was a mixing and matching so you're not, I guess it's not really. I wish it was a little more mix and match so it's like, hey, who knows what's coming next? Is it a positive product or sum? Maybe they do it later, so it's good that we kind of run into these to begin with just for practice. So factor the polynomial on these ones, it's all the same bit. The one difference, and this is where I'm going to write those things down again, is with a positive product, we now have a negative sum. So here's how I tend to write it. I say, hey guys, list your factors of 4. 4 times 1, 2 times 2. Okay, look at your sum, or a positive product, so still 4, negative sum, turn these negative. Negative times a negative, still a positive. Negative 4 minus 1 is negative 5, so it's going to be these two here, where we get v minus 4 times v minus 1. Something, of course, you can guess and check. You can double check. This is kind of guess and check. You can double check there. Now, another thing that might be asked, Mr. Robinson, what if none of these work? First, make sure you tried all your factors, and first make sure you calculated correctly. What if none of them work? Then it's not factorable. My guess is all of these in this section will be factorable. Someday, within IM2, you're going to see ones that are not factorable, but there are other things we'll do with them, especially when it comes to solving equations. X squared plus 13x plus 22. So factors of 22 are 22 and 1 and 11 and 2. I'm sorry, I don't know why I paused. I can't look at this camera lens while thinking. I have to look up. So and 11 and 2. When they're both negative, negative 22 minus 1, no, but negative 11 minus 2, yeah, that's negative 13. And when I say minus, I mean plus the negative. So x minus 11 times x minus 2 is that result. I want to keep them as x's. I don't like other variables, sorry. Number 11, d squared minus 5d plus 6. Let's factor. Okay. 6 is 6 times 1 and 3 times 2. Negative 6 minus 1 is negative 7, not negative 5. Be careful. It goes farther negative. Further negative. This is d minus 3 times d minus 2. Negative 3 minus 2 is negative 5. I'll tell you what. With the 6 and the negative 6, that gets the most mix-ups with the 6 and 1 and 5 because you can get some false positives with that. I swear. There are more mix-ups with that than anything else because you can have d squared minus 5d minus 6. And this is a way different factorization. I'll just say that right now. I hope we run into one that's like that. But it's just that's where I probably see the most mess-ups on them. Number 12, k squared minus 10k plus 24. Try and start thinking of your factors of 24 before I write this out. All right, you think of them? All right, let's list them out this time because there might be a few more than the last ones. We got 24 and 1, 12 and 2, 8 and 3. My head's bothering me a little bit. 6 and 4. Okay, not too many. 6 and 4. Positive product, negative sum means both are negative. If you test them out, you see we get negative 25, negative 14, negative 11, negative 10. So negative 6 and negative 4, we get k minus 6 times k minus 4. And I didn't box my last answer. That feels unlike me. All right. Let's move to the next page, but we're on number 13. W squared. Whew. Sorry. For those who are aware of my situation, I have concussion symptom issues. This is hard to look at. W squared minus 17W plus 72. You know what? Yeah, let's list our factors of 72 just to be sure on it. I have my answer already, but let's see how it can get a little expansive. So 72 and 1, 36 and 2, 24 and 3. By the way, if you get to use a calculator, just type in what is 72 divided by 1 to get them. So as you know, I'm working through my own internal, division, that you can also do it in the calculator to get them. Don't just start trying to guess randomly. Oh, what things of 72? Try and get them all listed and in order and bigger to smaller, because that way you can arrange things kind of better that way. I hope that kind of makes sense. Anyway, let's see, with 4, 18 and 4, I think. 18 and 4, not by 5. 6, yes. 12 and 6. 7, no. 8, yes. 9 and 8. Now at that point, right, 8 and 9 is just a repeat of that. Now you might notice that 9 and 8 end up being it, or negative 9 and negative 8, as you would turn all those negative and get your test. But it looks like that it's those two down at the bottom that give you negative 17 when you add. That's why I said, if you know common factors, maybe try it first. I mean, to get this one, this number has to be big. It would be negative 73. It would be literally just one right next to it. But those don't come as commonly. Ones that add to something a little bit smaller, I think, will come a little more commonly. And who knows, the book might even restrict you to those kinds. They might not do some of the bigger ones. What's the odd? What are the odds they're going to do 4 and 18? I mean, I don't know. Maybe the book does, but it's good to list them. Number 14, we have j squared minus 13j plus 42. They seem to be within the realm of the more basic multiplication, kind of within 10, 12. Positive product, negative sum. Let's factor that. 7 times 6 is 42. Negative 7 minus 6, negative 13. That ends up working out. And I feel bad in just giving the answer there, but I'm really talking about that process. If something's common, give it a shot. Did you know 42 is also 14 times 3, 21 times 2, 42 times 1? Try the common one first. So that's a strategy. There are remember, this is a guess and check. There are math number sense strategies to these that you can get fast with it. I think I'm going to plug this in my next video, but I have a video called I'm doing it right now. I have a video called Factoring Factory, where I literally do like 300 factored problems of, these are the very basic ones. I don't think I do any of these, but ones that are more complex for IM3 folk and what you can learn later. And I do it within like whatever time. It's all about speed. It's all about efficiency at this point. You're expected to be able to do these kind of fast at some point. All right. Numbers 15 to 24 factor. Now in these ones, it looks like the product is always negative. We have x squared plus 3x minus 4. So this time, check out how I kind of work out the process if you need kind of the slowed down version. List your factors of 4. Notice I didn't say negative 4. Just list your factors of 4. Just don't get blinded by which one's positive, which one's negative yet. We have 4 times 1 and 2 times 2. Okay. The product is negative. That means one of these is positive, one of them's negative in both. But should I do both sets? No. The sum is positive. That means the smaller number is negative. Now, 2 and negative, that's the same size. So it has to be 4 minus 1, and that is 3. That works out. But I'm avoiding needing to use these ones. I guess negative 2 and 2 is still the same thing. But I'm avoiding having to use more. And you can tell when we get larger lists how that matters to weed out half of the filtering. This does become x plus 4 times x minus 1 because 4 minus 1 is 3. So that is the result. But once again, we're now looking at a positive product and a negative sum for these ones. Excuse me, a negative, what did I say? We're looking at a negative product for these ones. Some sums will be positive, some sums will be negative. Z squared plus 7z minus 18. Factors of 18 are 18 and 1. And sorry for this visual. There's no reason for me doing the the little box. I just write that for you guys. 9 and 2, 6 and 3. Positive product still. Which one gives me 7? 9 and negative 2. That becomes z plus 9 times z minus 2. Number 17. N squared plus 4n minus 12. I'm not going to list these out. I'll say them out loud as we see them fit. Notice that the sum is still positive. That means the number, the bigger number is the one we're going to look at. So 12 and 1, 12 minus 1, no. 6 and 2, 6 minus 2, yes, 4. The other one would have been 4 minus 3, which is 1, which does not work. So n plus 6 times n minus 2. Again, factors of 12, do one minus the other. Now, I'll say this as well. Even if I had to think about it, I tend to write the parts that I already know first. So I'll do this for this next problem, number 18. I think I'm trying to process with you instead of process how I would. And I part of the problem is I know the answer beforehand because I can see. I've done these since 7th grade. You know, seventh grade was 23 years ago. So, you know, it's just something where, and I've taught it, right? So it's something where I see the numbers and I know what the numbers mean in my head. Not like a memorization thing, but a familiarity thing. So here's how I would do it if I was factoring. Remember, those are S's, not 5s. I would do this. S, S. Negative product means one's positive, one's negative. The positive sum means the larger number is positive. So now we're trying for 40. And you could, I don't do this part, but 40 minus 1? Nah. 20 minus 2? Nah, you know, like that. This ends up being not 10 minus 4, 8 minus 5, right? 8 times 5 is 40. 8 times negative 5 is negative 40. 8 minus 5 is 3. So kind of filling some things out, that's kind of a way you can go about that, you know, if you really had to think about it. Maybe not so much for these ones, but I especially do them for what you're going to see in section 2.6. Write as many things as you can so you don't have to think about them in your head. Get as many visuals out there as possible. All right, 48. Now, once again, you can try some popular ones. Obviously, 48 minus 1 isn't going to give you 2. I like the 6 and 8 thought. And 8 minus 6 is 2, positive 2. So once again, y plus 8 times y minus 6. Going back to the idea of you can write this in either order as long as it's y minus 6, not y plus 6, with y minus 8. That would give you a negative 2y. Number 20, h squared plus 6h minus 27. Factors of 27 are 27 and 1 and 9 and 3. Looks like 9 minus 3 will give you 6, so I'm just giving that answer as well as we process that. The other hard part about this, you know, like I said, is because I already know the answer, it's kind of hard for me to have that, you know, like I'm seeing these problems for the first time, but to have that, like, learn it with you as I go and process it with you. But there's that 9 minus 3 here. Because, you know, I don't really want to play dumb on it either. Is it this? No. Like that. Okay. It's kind of hard to do both. I got to make it a brand new and exciting video. Number 21. So check this one out. This time we have x squared minus x minus 20. Couple new things fly in the ointment this time, and I'll actually write this one out. Number 1, the sum is negative. Number 2, I don't see a number with x. What's going on with that? Well, remember, just like this is 1, that means this is 1. The important part about that is you're trying to find two numbers that multiply to negative 20 and add to negative 1. So make sure you know what that number represents. Now, factors of 20 are 20 and 1, 10 and 2, 5 and 4. However, because this time the sum is negative, that means the larger number is negative. So which one adds to negative 1? The one that are 1 apart. 4 and 5 are 1 apart. So it's these two. This factors into x minus 5 times x plus 4. So in this case, negative product, negative sum, 1 positive, 1 negative, the negative number is the larger one. Number 22, m squared minus 6m minus 7. This is one of those, I'd say as straightforward as you can get. It's just like that number 3 earlier. 7's a prime number. It's only 7 times 1. So the book will say your two options are either 7 and negative 1 or negative 7 and positive 1. I say your only option is negative 7 and positive 1 because this is a negative sum. Does negative 7 plus 1 equal negative 6? Yeah. So this becomes m minus 7 times m plus 1. Okay, number 23. Now, I've mentioned time and again that standard form is key, it's crucial, and it's important. Here's among the reasons why. this being out of standard form doesn't grant me what I kind of need for my setup on the thing. The two numbers that multiply to b and add to c, b is the linear coefficient, c is the constant. You can look for where those are, but I think it better suits you to have this written t squared minus 6t minus 16 to really find them for where they are, and for when you write the factorization, if distributed out, it would go back to this format. The t plus this and t minus that kind of thing. So, that being said, now that we're in standard form, I am finding two numbers that multiply to make negative 16 and add to make negative 6. Now, one positive, one negative. The positive number is bigger. So, 16 minus, 1 minus 16, no. 2 minus 8, yep. So, negative 8 and positive 2, that gets you your negative 6 value. But again, getting in standard form was a pretty crucial step to me, I'd say, at least. And number 24, negative 7y plus y squared minus 30. Once again, the same thing. Let's first get it into standard form before you proceed. By writing the y squared term first, and then negative 7y and negative 30. 30, you have, we talked about 5 times 6. Does that work this time? Negative 6 plus 5, not negative 7, so it's not that one. 30 and 1, too big. Negative 10 plus 3, otherwise we would have tried negative 15 plus 2. But negative 10 plus 3, so y minus 10 times y plus 3. Once again, I'm trying with the larger number, negative, in that case. Now, I'll also say this. I don't like to say negative 10 plus 3 as much as I like to say 10 minus 3. And I know that 10 minus 3 is positive 7, not negative 7. But I know the only difference is I got to switch the signs. That's what I do in my head. Whether I say that out loud or not, that's what I do in my head. A difference is just I'd rather do big minus small. I'll change the signs as needed. And knowing that it's a negative sum means that's what we're going to get. Okay, number 25, modeling with mathematics. A projector displays an image on a wall. The area in square feet of the projection is represented by x squared minus 8x plus 15. Write a binomial, so 25. Write a binomial that represents the height of the projection. I'm sorry, the area of the... So a projector, so is the map, so I'm confused because is the project... I'm going to copy and paste this thing over. Is the projection this big canvas thing, or is it just the little map guy? Let's see. Let's see if I can figure that out. A projector displays an image. Oh, okay. So X is the wall. Got it. I thought that was part of the projector screen, so I didn't know whether we'd call that a projection or not. Okay. So what did they say? The area in square feet of the projection, this thing, is modeled by, I don't know how to get this in a color that'll be visible. X squared minus 8x plus 15. Okay, write a binomial that represents the height of the projection. So they give us one of them. So what they're helping you to do for this is come up with what the other part would be. So x squared minus 8x plus 15, it's going to equal, it's going to equal apparently x minus 3 times something. So x minus 3 times, If negative 3 is one of your factors, negative 3 times what gives you positive 15? And do those add to become negative 8? Well, negative 3 times negative 5 is positive 15. And negative 3 plus negative 5 is indeed negative 8. So your height is x minus 5 feet. Right? So this guy here becomes x minus 5 for the height of it. That's part A. Part B, I don't know what I was going to write up here. Find the perimeter of the projection when the height of the wall is 8 feet. Why does that have to do? Oh, because x is the height. Good. Okay, so x equals 8. That's their way of saying that. So the perimeter, we're going to be doing, okay, we're going to be doing 2x minus 5s plus 2x minus 3s, which simplifies to 2x minus 10 plus 2x minus 6, which simplifies to 4x minus 16. Now, when x equals 8, we're going to be getting 4 times 8 minus 16. No, you didn't have to do it that way, but I like to use the algebra when I can. 32 minus 16 is 16. So the perimeter is 16 feet if the height of the wall was 8 feet. Okay. Okay, halfway through the problem set, and those are probably the faster problems to begin with, so 50 minutes in. Okay. 26. Modeling with mathematics. A dentist's office and parking lot are on a rectangular piece of land. The area in square meters of the land is represented by x squared minus x minus 30. So the whole thing is x squared plus x minus 30. Okay. Write a binomial that represents the width of the land. I was going to say this is the width of the land because that's what apparently length is always longer than width. So we're looking for this thing right here for part A. So for A, boom. Okay. So we're trying to find that guy. Okay. Well, hey, let's do it. If the whole area is x squared plus x minus 30. I mean, here's the thing. We could factor on our own, but they clue us in. It's x plus 6 times something. What's the other guy? Well, we got to multiply 6 by something to get negative 30. That number would be negative 5. Does 6 minus 5 give you 1 as well? Yes, it does. So the width is x minus 5 meters. X minus 5 meters. That is part A. Part B, find the area of the land when the length of the dentist's office is 20 meters. So the length is probably the longer portion. That's once again x, right? So x is 20. So we're going to find the area this time. The area is multiplying these two together or, of course, substituting into here. So we could do 20 squared plus 20 minus 30. The area of the land, right? Which is 400 plus 20 minus 30, which is 390 square feet. I hope I'm not botching an idea of what they're asking me to do for the problem. It looks like the x minus 8 isn't even used for this problem, unless I'm totally misinterpreting a part of this. Because they're saying find the area of the land, not the office, right? Now, that's one way of doing it. We could have also substituted 20 into here to get 20 plus 6 times 20 minus 5, which is 26 times 15. And 26 times 15, it confirms 390. It is. So you get 390 square feet. Oh, meters, not feet. Square meters. Boom, and boom. Okay, it's number 26. I'm just going to turn that page. Let's go to numbers 27 and 28, error analysis. Describe and correct the error shown. Okay, x squared, so 27. X squared plus 14x plus 48 equals x plus 4 times x plus 12. Okay, what is the error for this problem? You know, I shouldn't have written that first. I like to type the error and then just correct what's there. So, okay, what is the error? Well, it's factored wrong. I mean, I'm trying to think about the best way to say that. Like, they screwed up, right? So, now, how did they screw up? I guess that's the explanation part. Although 4 times 12 equals 8, although they found correct factors for the product, you know, that you seek for the constant for C, the sum is not correct. Must seek elsewhere, right? Must try and find another set. So although they found that, the sum is not correct. So we got to go and factor it differently, right? We got to find out what it is. So what are factors of 48? 48 and 1, 24 and 2, 16 and 3, 12 and 4, which was wrong. 5, 6, 8 and 6, and then it goes to 6 and 8. So that's it. Now these are both positive, so 40, no. Oh, 8 plus 6, there it is. So this will equal x plus 8 times x plus 6, and that's the correction. Okay, next one, S squared minus 17s minus 60. Oh, okay, so this is one of those false positives that I was kind of referring to before. Cool. So take a look at this. S squared minus 17s minus 60. Now they put, oh, I shouldn't put that yet. 28. So they, negative 5, excuse me, well, 5 times 12 is 60, and 5 plus 12 is 17, that kind of thing. But negative 5 times negative 12 isn't negative 60, it's positive 60. They have the correct sum otherwise. So they have a correct sum with their factors. However, their factors are both negative and would lead to a positive product instead of the negative product we're looking for. So we're looking for other factors of 60 there. Now they actually went up to 12 this time. I guess they did in the last problem too. So what are factors of 60 in that way? So 60, I think we listed some before. 60 and 1. Oh, by the way, negative product, negative sum. The negative number is bigger. Negative 60 plus 1? No. Negative 30 plus 2? No. Negative 20 plus 3? Yes. Negative 20 plus 3 is negative 17. So S squared. Oh, my head. Or my eye. It's my concussion. S minus 20. They actually went up to something a little bigger. It's good to see. S plus 3. I'm having trouble. I'm just letting you guys know right now. I'll fight through it. Number 28. Oh, that was number 28. Okay, so sorry about that. Let's go to numbers 29 to 38. Numbers 29 to 38 solve the equation. Okay, so this is where they didn't do examples for you in the problem set except for the word problem from the examples, and that one also wasn't set equal to 0. So it's pretty interesting there. This is a good set to do, and this is what we're leading to. Guys, why do we factor? There are several reasons, but one of them is to solve equations. How do we solve this equation? Subtracting 2 won't help us here because we have two different terms that can't combine with m in it. So we factor. We find two numbers that multiply to 2 and add to 3. That's 2 and 1, baby. M plus 2 times m plus 1 equals 0. Now the good news is, once you factored it, we've practiced this before a bunch. I'm not even going to really say much on this part right here. What's really also nice is this is always an m times m. That means it's opposite signs. If this times this equals 0, either this equals 0, so m is negative 2, or this equals 0, so m is negative 1. Those are the two different answers that work in this right here. And I want to show just this one, and then we're good. Negative 2 squared would be 4, plus 3 times negative 2, that's minus 6. 4 minus 6 is negative 2, plus 2 is 0. Negative 1 squared is 1. Plus 3 times negative 1 is negative 3. 1 minus 3 is negative 2. Plus 2 is 0. Both of these work. Only ones that would work. Number 30. Now that we've gotten to the idea of factoring a little bit, I think I want to go a lot faster on these ones. However, if there's something new I need to introduce, I'll really make sure to talk about it. So n squared, I especially given my head, n squared minus 9n plus 18 equals 0. That would factor, oh, not to x. That would factor into a positive product and negative sum, means that both of these are minuses. So 18's got a few things, but 6 and 3 work itself out to get that 9, negative 6 minus 3. And there's that. Now this still equals 0. This is a lost step. Even if people tend to solve it or have to solve it, or you're not supposed to solve it, some people do this and they just start writing n equals 6 and n equals 3. No, not unless this equals 0. First of all, it needs to be an equation. Second of all, it needs to be equal to 0. And then you're like, well, I already wrote it up here. Guys, don't lose your equation in a problem. I know I'm skipping some steps in between right here, but I didn't lose my equation in the problem. Don't lose your equation in the problem. I don't know if the habits permeate to other students that aren't mine. And I'm not just picking out my students in particular. I'm just talking about people that I've taught. And so I assume other people do that. Keep your equation. The whole goal of this is that you do this when it's an equation set equal to 0. When it's not, you're not solving. There's nothing to compare to. It's important that it's set equal to 0 for this to even be considered. So x, numbers that multiply to 14, 14 and 1, 7 and 2. Negative product, 1 is positive, 1's negative. 7 minus 2 will give me 5. So that will set this thing up. So x can either equal negative 7 or x can equal positive 2. There's part of the speed. Number 32. This question looks a little familiar. It reminds me of that problem. It's the same problem, but with x's instead of v's. I said I wouldn't factor it. Guess what? We're factoring it. The first thing I wanted to say was, is it factorable? Yes, it is. Number 32, v squared plus 11v minus 26. 26 kind of puts me at pause because it's not a very common number that we see to factor things, either 26 and 1 or 13 and 2. I guess because its only factors are, its bigger factors, only bigger factors are all more than 12. 13 and 2. 13 minus 2 is 11, and 13 times negative 2 is negative 26. So v either equals negative 13 or v equals 2. Now again, don't start feeling too comfortable with the whole just switch the signs, especially when we hit the other factors. We've practiced those before, so I really do wish that, or well, no, actually there's no wish to this. I really do hope that you are able to recognize that. All right, look at 33 to 38. Something's a little bit different on these. Some might not be in standard form, but more importantly, they're not set equal to 0. And unless you set it equal to 0, there's no zero product property involved. Because I'll tell you what, I can factor this by a GCF, a greatest common factor, t times t plus 5. But I ain't solving that way. It's not t equals 0 or t equals negative 5 because it's set equal to negative 36. That guy don't exist. I don't want to factor yet like that. I need to add the 36 over to both sides, set it equal to 0, and then factor this thing. Oh, okay. T. Oh, I'm going to have to pause this thing. Did I write something different? Hold on a second. Oh, 15. I was going to say, this isn't factorable. Okay, so now it's factorable. So 36. 36 times 1. 18 times 2. I'm having trouble. 12 times 3. 12 and 3. 12 plus 3 is 15. There we go. So t equals negative 12 or t equals negative 3. Number 34. N squared minus 5n equals 24. Once again, we have to get that 24 on this side of the equation. N squared minus 5n equals 24. So we're going to subtract that over. We got n squared minus 5n minus 24 equals 0. Good. Now we're going to go ahead and try and factor this guy. 24, 6 and 4, 8 and 3, 12 and 2, 24 and 1. 8 and 3 look good. 8 minus 3 is 5. I want negative 5, so let's do negative 8 and positive 3. That'll work itself out. Set equal to 0. N either equals 8 or n equals negative 3. I really should be putting the or in between, but there's only so much writing I can do. I got to save that word or. You're like, it's just a single word. Well, when you have to write it, how many problems did we have for drill and kill so far? We have to write like 30 times. It adds up. A squared plus 5a minus 20 equals 30. So once again, not set equal to 0, even if, which doesn't look like it is, even if this quadratic was factorable, this quadratic trinomial, without a GCF, still not set equal to 0. I got to subtract 30 over first, and we get minus 50. 50, 5 and 10, popular one. It looks like you can work something off of that. Otherwise, 25 and 2, 50 and 1. 5 and 10. 10 minus 5 is 5. So that'll work out. A plus 10 times a minus 5. So a either equals negative 10 or a equals positive 5. Like so. Number 36. Y squared minus 2y minus 8 equals 7. Y squared minus 2y minus 8 is factorable, but it's not set equal to 0. So we only hope that when we subtract this 7 over to this side that it remains factorable, and it looks like it will. It's a different factorization, but that's the point. You're finding values of y that make 0 now instead of finding y's that make 7. So this guy factors into y minus 5 times y plus 3. You have negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. I was, of course, hunting for negative number bigger in that case. So y equals 5, y equals negative 3 is the result. Again, the opposite of these. 5 minus 5 is 0, things like that. Number 37, m squared plus 10. That wasn't a question. M squared plus 10 equals 15m minus 34. Now I got to move two things over. I'm going to subtract the 15m over, put it in standard form, minus 15m, and add the 34 over with 10, combine it to get 44. You see 44, you see a number like that, you're thinking 11 times something. I absolutely am. Positive product, negative sum means that both of these will be negative, and 11 and 4 seem to fit the bill. Negative 11 minus 4 is negative 15. That's not me being lucky. Well, it might be me being lucky, but it's me using my strategy of what's a common one that I want to test right there. There's 22 and 2. And 44 and 1. M equals 11 and M equals 4. Great. Notice how all these have two solutions. I mean, there's a possibility of one. We've seen those repeated roots, but no, not here. You know where you'll see it? 2 sections from now, 2.7, with the perfect square trinomials. Number 38, b squared plus 5 equals 8b minus 10. And by the way, I keep saying you put these to one side of the equation. I mean, that doesn't change. I'm going to subtract these over, add this over, whatever. But, Mr. Robinson, does it matter what side you put it over? It kind of does. And it's not about left versus right. It's about, is your b squared positive or not? You want this positive. You want your leading quadratic term positive. It better yet a positive 1 in these cases. It's really going to save everything we're doing. Factoring is a lot easier. So it's not about right versus left side. It's about keep this positive or make it positive. Subtract 8b over and plus 10 is plus 15 like that. Set equal to 0. 15 is, 5 and 3, 15 and 1. So negative 5 minus 3 is negative 8, for example. And those two positives, multiply to become positive 15. Those two negatives multiply to become positive 15. Really struggling, guys. B equals 5 or B equals 3. And I'm sure I still have all the word problems and things like that to go, but there are some. Okay. Still have, I think, several. Yeah, look at all this stuff. Modeling with mathematics, number 39, and number 40 says that as well. You trimmed a large square picture so that you could fit it into a frame. The area, trimmed it. Okay. The area of the cut picture is 20 square inches. So the part that you cut is 20. Okay. What is the area of the original picture? Oh, that's not a color you can see. That's barely a color you can see. Is blue fine? Oh, yeah. Oh, totally. Let me put it over the red. So that's 20. What is the area of the original picture? Okay, I'm going to just kind of work off this page right here and just kind of talk about what we have. I didn't see these were x's. So I got an x right here, and this is 6. That means that this is the difference of that. This guy here would be x minus 6, like so. And this guy is x right here, and this is 5. So this will be the difference here, which is x minus 5. So they're asking what the area of the original picture is. Now, the original picture is the big guy, and the big guy, we need to know what x is for this. But we want to represent. We want to represent a part that we know that we can use x with to get an answer out of it. The area of the cut picture is 20. That's a base times height thing. If I multiply x minus 5 with x minus 6, I'm getting 20. Our goal is to solve for x. Now, this is not 0 product property. Currently, this is the 20 product property, which is not a thing. This is what we had to do in one of our example problems. We got to FOIL this first. And I know that sounds like it goes against what I used to say before. No, leave in factored form. That's when your factorization set equal to 0. We need to get the set equal to 0, but this 20 is in the way. I got to FOIL this thing out. First, outside, inside, last. And by the way, given that outside and inside thing, it's all about negative 5 minus 6. They have x's on it, but we've been talking so much about these being the sum that represent, what, negative 11, right? This all equals 20, like that. So what does this 20 help me with? I subtract it over, and I can combine it with the 30. 11x plus 10 equals 0. Boom. Set equal to 0. It's not factored yet, though. If this is factorable, boom, boom, then we can set it equal to 0 and solve through that. 10 is 10 times 1 is 2 times 5. 2 and 5 was the common one you like to try first. It didn't work. So 10 and 1 seem to work there. To get negative 11, both are negative like that. So x can either equal 10 or x equals 1. But we're not done with the answer for a couple reasons. Number one, they asked us to find the area of the original picture. Number two, I got to see if 1 actually works as an answer. I don't think 1 works because 1 minus 6 and 1 minus 5 would give me both negative values. 1 is already less than the 6. That's only a portion of the picture. 10 seems to be the only one that actually works in this scenario. There often aren't problems where both would actually end up working. I don't really see many that can do that. Maybe they can't at all. So if x is 10, your area it's x by x. It's 10 by 10. 10 squared, which is 100 square inches. So we had to solve for x given that area model, and that pans out. That's number 39. Number 40. A web browser is open on your computer screen. Okay, x plus 7 is the width of the... Okay, the area of the browser window, the small guy, is 24 square inches. Find the length of the browser window x. So this guy's 24. We got to find x. X plus 7 here might just be a decoy, or, it's a part of B, I guess. So on A, find the length of the browser window x. Same thing as the previous problem. I'm going to multiply length by width, x times x minus 2, and I get 24 out from it. However, I need to set it equal to 0 and kind of refactor. I got to first distribute x. X squared minus 2x equals 24. And now I can subtract 24 over, set it equal to 0. So x squared minus 2x minus 24 equals 0. And now let's factor this guy. For the sake of time, I'm going to go ahead and speed this up. This is x minus... Well, hold on. That's wrong. I was thinking of something else. This is x minus 6 times x plus 4. Boom. So x either equals 6 or x equals negative 4. Now, forget the whole let's plug in x to subtract 2 from whatever. Negative 4 in itself already a negative value. That part can't be negative 4 right there, much less this be negative 4 minus 2. Negative 4 doesn't work as an answer. 6 does. So x equals 6. So they said find the length of the browser window x. It's 6. 6 inches. For the length. That is part A. Part B. The browser covers 3/13 of the screen. What are the dimensions of the screen? You got to be kidding me. The browser... Oh, boy. The browser covers 3/13 of the screen. What are the dimensions of the screen? Okay. I don't know what you guys have covered or not based on area ratios. But let's talk about the area bits. Okay. The browser covers... Oh, this is already... Okay, that's probably fine. Okay, we probably don't have to do area ratios. Okay, 3/13. 3 to 13, this area ratio means if I got the area of the browser window that's 24, that area of the bigger guy is x. Sorry, I shouldn't put x. I should put something else. I should put a. Some unknown, right? Area of the big guy. If I cross multiply here, I got 3a equals whatever 24 times 13 is. 312. And then you divide both sides by 3, and you get a is 104. Now this is the area of the larger guy. Now, being 104, we are going to... Let's see what they're looking for. What are the dimensions of the screen? X plus 7 is the width of this thing. We have to find a way... I got to think about that. We got to find a way to represent something with the height. Because it's x plus 7. Are we using the same... Oh. Are we using the same x as before? we might be using the same x as before. Okay, that's fine. I was going to say I don't have an expression otherwise for this. So we have length, base times height, let's call it that. Base times height equals 104. Now, our base is x plus 7. X plus 7 times height equals 104. But x is 6. So 6 plus 7 times height equals 104. Now, this is the magic of me seeing a problem for the first time and working it out. 13h equals 104, and divide by 13, h equals, I don't know my multiple is 13, so 52, 88. Okay, I just got it and I lost it. Is that 8? 8 inches. Okay, so if the width is 13, or that base length is 13, so the dimensions are 13 inches by 8 inches. I don't know if that's typical monitor dimension behavior, but it might be the width of the display, not just the screen itself. So maybe. Okay. Hopefully that made sense with the problem. We set it up with a ratio 3 to 13. We're 24. Yeah. Hopefully that worked out. Okay. Number 41. Still got 11 problems to do. Your friend says there are 6 integer values of b for which the trinomial x squared plus bx minus 12 has 2 binomial factors of the form x plus p and x plus q. Is your friend correct? Explain. Are they talking about possible ones or actual answer? Oh. I got you. Okay. They don't say whether b is positive or negative, do they? 6 integer values for b. So they don't actually tell you what the sign is. So, okay, because I was about to maybe counter something on them. So x squared plus bx minus 12. Now, what we do for factors of 12 in that case is we list out our factors. We got 12 and 1. Now, I'm going to list them twice, and I'll show you why in a second. 12 and 1, 12 and 1, 6 and 2, 6 and 2, 4 and 3, 4 and 3. The reason why I'm listing them twice is because it's actually not a 12, but a negative 12. And a negative 12 can be, see, b, I don't know if b is positive or negative this time. So this is the time where it's this alternation. 12 minus 1 and negative 12 plus 1 are 2 different values. One positive version of the thing, one negative version. So these are the 6 different ones I can think of with factors of 12. The friend says there are 6 binomials of the form. 6 integer values for which the trinomial has 2 binomial factors of the form. Is your friend correct? Yes. So yes, your friend is correct because, where's my mouse? There it is. So yes, because a negative product requires that you, only if you don't know whether the sum's positive or negative, requires that you test both positive and negative. How do you spell positive? Positive and negative versions of all factors of 12 for which there are 6. Whatever. There are 6 different sets. So yes, your friend's correct. If there's a coin toss for how many times your friend's correct versus incorrect, it looks like they kind of alternate. I'm going to guess next time the friend will be incorrect. Just because. Okay. 42, thought-provoking. Use algebra tiles to factor each polynomial modeled by the tiles. Show your work. Okay, I'll say this. We didn't go for algebra tiles. I can see what it works off of, though. You probably don't know what these mean, so I'm just going to go ahead and display them for you. In part A, that plus, first of all, pluses mean positive, minuses mean negative. That thing that's a square, that's an unknown length of some x by x. That represents an x squared. The next part is, it's a length. So this thing here was an x by x. The next thing is some sort of guy here where this length is 1. That's the unit length, and that's an x. I've done algebra tiles in the past. So that would be an x. X times 1 area is x. Remember, this is x squared, this is x. But it's negative. So they want a negative x. And then they have these little guys, which all have 1 by 1, which is 1. And if they're all negative, there are 1, 2, 3, 4, 5, 6 of them. X squared minus x minus 6 is that first guy that shows up, just so you're aware. And for b, before I factor this one, for b, we're looking at what then? We're looking at x squared plus 2x minus 8. So I guess you needed to know algebra tiles to get to that, and we're not doing those. X squared minus, I'm not doing it with my students. X squared minus x minus 6 factors into x minus 3 times x plus 2, where we have, and remember, we're not setting equal to 0 and solving using zero product property there. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. X squared plus 2x minus 8 factors into x plus 4 times x minus 2. 4 minus 2 is 2. Whoops. 4 minus 2 is 2. And 4 times negative 2, of course, is the negative 8. Oh. I'm thinking. I'm not going to say what I want. Oh, well, okay. I was wondering if they're saying use the tiles, like actually like have tiles and use them. Now, a reason why I would go against, even if I had them, a reason I would go against using them in this case is because we have some that are negatives. And if there are negatives, negatives are technically taking away from area. So unless they were actually all positive to deal with, I don't know how usage of tiles actually works unless you create two different sets of tiles with them. So I'm not even playing their game with that. But that's the display of them. That's as best as I can do in video form. And I think that's the best that you can do for the problem, really. All right, number 43 and 44. Find the dimensions of the polygon with the given area. So you have to actually solve for x in 43. You have to solve for 44 in g in these problems to actually work them out. So I'm just going to use the figure that you have. Notice that we're going to multiply x minus 12 with x minus 5 to get 44. And this is once again one of those problems where we got to distribute this out by foiling. So minus 5x minus 12x is negative 17x and plus 60. I'm going to subtract 44 from both sides. It combines with the 60 and I get 16. And now I go and factor this. By quick factoring, that's x minus 16 times x minus 1. And using the zero product property, of course, once I subtracted the 14 over, we get x equals 16 and x equals 1. Now, what has happened quite a few times here is the 1 is too small to work. 1 minus 5, 1 minus 12 are negative. 16 seems to work out just fine when it comes to the x. We still need the dimensions of this thing. The dimensions, 16 minus 5 is 11. Minus 5 equals 11. And 16 minus 12 equals 4. So the dimensions are 11 feet by 4 feet, like that. And 11 times 4 is 44, and that seems to work out. Number 44. Sir. Area is 35. Now this is a triangle. It's not a length times width. It's 1/2 base times height. 1/2 of base times height equals 35. Now the first thing I want to do, there's the foiling aspect. I'll definitely get into that. But I want to multiply everything by 2. I am not going to be dealing with a fraction in this. I never would. It's not a matter of my head's bothering me too much or anything like that. Never dealing with that kind of fraction. No siree, Bob. So before I foil, let's go ahead and write that as 70. Multiply everything by 2, and that's what you get there. Now let's go ahead and foil this thing out. I got g squared minus 11g minus 8g plus 88 equals 70. Subtract 70 from both sides. G squared minus 19g plus 18 equals 70. This is one of those instances, again, hopefully you see what this does factor to. We talk about test factors of 18, and it's this and this. This is the one, and so is the last problem, where it is 18 and 1 and 16 and 1. They're both negative, but that's because they get positive g values. But this is g minus 18 times g minus 1. That negative 19 is just so big that it's actually what brings it. I don't know why I still have a 70 here, though. I was too much thinking about the other step. I shouldn't factor if it's not set equal to 0. And you solve, you get g equals 18 and g equals 1. And I can only imagine that the 1 doesn't work. It will not work for this problem here. So g equals 18. They are asking for the dimensions. I don't know how you say dimensions for a triangle. Do you still just say this by this, I guess? You say it's a right triangle with these dimensions? Okay. So g is 18. 18 minus 11 equals 7. And 18 minus 8 equals 10. So this the dimensions are 10 meters by 7 meters. Do they want the hypotenuse? I don't know. I'm not doing a Pythagorean theorem there, but yeah. So 10 meters by 7 meters for the triangle. Sure. Number 45. Write an equation of the form x squared plus bx plus c equals 0 that has the solutions x equals -4 and x equals 6. Explain how you found your answer. Well, there are a couple ways that we can talk about the explanation on that, or, the process in doing this. Bx plus c equals 0. X equals -4 and x equals 6. They kind of end up being the same thing. If these are the solutions, that means when I add 4 over, this ended up being one of the, x plus 4 ended up being one of the factors. When I subtract 6 over, x minus 6 ended up being one of the factors. I was just basically going to say that if these are the answers, what you see in factored form is the opposite sign. So as far as factored form goes, x plus 4 times x minus 6 equals 0 is the appearance of the ones that get those solutions. So let's FOIL this thing out, or without necessarily foiling, 4 minus 6 and 4 times -6 show up in the result there. That is foiling. But yeah, it ends up being that. What do they say? Write an equation in the form. There it is. X squared, let me write it better. X squared minus 2x minus 24 equals 0. Explain. I said it out loud. Basically, start from the solutions and work backwards into when they're set equal to 0. Those are the things that represent the factors. And they said set it equal to 0, and we're good. Okay, number 46. How do you see it? The graph of y equals x squared plus x minus 6 is shown. Ooh, we're going to be able to graph someday in another chapter. Chapter 3, I believe. The graph of that is shown. Explain how you can use the graph to factor the polynomial x squared plus x minus 6. So I think what they're asking you to do, well, hold on a second, this is part A. I think what they're asking you to do is, let's say you didn't know how to factor. I guess that's how they're saying it. And use the explanation, use an explanation here. So here's the idea. The graph shows these x-intercepts. These x-intercepts are solutions to your equation when y equals 0. If you set, this is what I'm going to start typing. If you set y equal to 0 and solve for x, you find the x-intercepts. The x-intercepts here are 2 and -3. Those are the same kinds of things as what were right here. And those zeros allow you to write the factored form as the opposite sign. When you set, this could be a long explanation. The x-intercepts are when y equals 0. Oh, okay. I guess that's a fast way of saying it. The x-intercepts are when y equals 0, and their opposite signs are what appear in factored form of the polynomial. So let me demonstrate that. This x-intercept is 2. This x-intercept is -3. So when you have those x-intercepts of -3 and 2, that means that x equals -3 and x equals 2 are solutions, where x plus 3 equals 0, x minus 2 equals 0, and in factored form, that would be an x plus 3 times an x minus 2, like that. Now that equals 0, but ultimately we're looking for the y equals. Y equals x plus 3 times x minus 2. Now, I didn't try and factor the original before. What was the original polynomial? X squared plus x minus 6. What two numbers multiply to make -6? 3 and -2. Does 3 minus 2 give me 1? Yes. So that ends up being it. So that's my explanation on that. Part B, factor the polynomial. Well, there you go. Okay, so that's part B. Okay. Number 47. I think I have 5 more. Yeah. Problem solving. Road construction workers are paving the area shown. Okay. Write an expression that represents the area being paved. So, okay. We have different versions of what we could write. I think I'd like to do a... Okay, we can do, if this is x and this is 18, we can call this part 18 minus x. We can just do a rectangle plus another rectangle. So like that. So I got an 18 minus x right there. So write an expression that represents the area being paved. We have 47. We have the bigger guy, the one on the bottom, as x times 20. So 20x. And then plus, we have the other guy that is x times 18 minus x. Oh, I thought we were going to do... Oh, there's a quadratic. So we have 20x plus 18x minus x squared. 20x plus 18x is 38x. Written in standard form, it's negative x squared plus 38x. For the first time... I don't know if they're going to ask, well, it's not a factor. Okay, anyway. Negative leading coefficient. Okay, that's part A. Now, there's more than one way that we could have gotten to this. We could have taken like a whole square, this 18 by 20, and subtracted out these little parts here. I don't think I would have had as much fun with that, but it's possible. Hold on a second. Let me come up with that version. I want to see what that other version looks like. An alternative answer to this would have been you take 20 times 18, or you take 20 times 18, and then we take away what would have been, oh, yeah, we'd still get there, I think. So both of these are basically equivalent. I could shift that over, and then this would be a length of 20 minus x times 18 minus x. I think that's what remains inside of there. So what would happen there? We'd have 20 times 18, which is 360, minus, now in this quantity, when I FOIL, I have a 360, and then minus 20x minus 18x is minus 38x, and then x times x is x squared, so plus x squared. Distribute that negative. I have 360 minus 360 plus 38x minus x squared. 360 minus 360. I know better than to say that you get different answers for expressing this. You get negative x squared plus 38x. So you get the same thing. I knew better than to say that. I was just thinking, where did the 360 come into play? It goes away afterward. That works out. Okay, part B. The area being paved is 280 square meters. Write and solve an equation to find the width of the road x. Okay, so we have negative x squared plus 38x equals 280 square meters. This is an expression for the area of the entire paved road, and this is the thing here. Now, this is a first-time problem where we have the x squared term that's negative that is actually consequential to what we do. I do want to set this thing equal to 0, but I do not want to subtract 280 over because I need my x squared term to be positive. It is an absolute must if you want to factor using what we've been doing so far. I can't subtract 280 over and say what two numbers multiply to negative 280, add to 38, and assume everything's good. Because x times x is not negative x squared. It's positive x squared. So I'm going to add x squared over. I'm going to subtract 38 over. And I get x squared minus 38x plus 280. And that's equal to 0. Now I find two numbers that multiply to 280 and add to negative 38, which is actually different circumstances. Positive product, negative sum. Both of these are negative. And that's a pretty big list. But if I think hard enough, 280, 30 times 8 was... No, sorry, I was thinking of sums first. Let's go to 280. I should be better at this. Was it 280? Okay. I don't do factors of 280 here. Oh, 28 and 10. I was thinking of 18 and 10 to begin with. Okay. X minus 28 and x minus 10. So x can either equal 28 or x equals 10. They say find the width of the road x. Is there a problem? And here's another interesting part about this. Remember how the numbers that were too small were a problem? Take a look now. We have an 18 minus x. 28 is too big. 18 minus 28 would be a negative result. 28 doesn't work. We need 10. 10 is the only one that works. Plus, you can tell with 28 that would be too big for that 18. I guess that's part of the problem. 10, Find the width of the road X. The width equals 10 meters. All right. See, there is good use to be able to be putting those in. 4 more problems where they ask you to factor the polynomial. Now, these have different variables in it, and I think before I solve these, I want to go back to something that I've talked about before, if you've heard it, about standard form. How important it is for these kinds of problems. And then we'll kind of talk about this work. These all have degree 2 because this is 2 squared and 1 plus 1 and 2. But the tie, when it comes to standard form, which one do you put first? The tie goes to the dominant, the alphabetically first variable is the dominant one. This x is squared. X is alphabetically before y. This x is squared. This x is to the first power. There is no x here. So we go in this order. Why is standard form important? Because we treat x as the true variable in this problem. Now, you might be confused on what to do with this problem so far. Let me give you a perceptual change in how this problem can be rewritten. Treat x as the true variable. This is 1x squared plus, check this out, we'll call this 6y times x. So 6y is the coefficient plus 8y squared. We're trying to find 2 numbers that multiply to make 8y squared and add to make 6y. And I know that sounds weird, but keep in mind, it's going to look like this. First of all, everything's positive. So we're going to be adding. Second of all, it's not so weird. These are just going to have y in it. Think about it. A y times y is a y squared, and a y plus y will combine to become like a 6y. So really what you're doing this. X squared plus 6x plus 8. What 2 numbers multiply to 8 and add to 6? That's 2 and 4. 2y times 4y is 8y squared. 2y plus 4y is 6y. And that's how that thing combines and works out. So here's a perceptual difference change. Here's a perceptual difference change. Any of those things can help you. The bare basic bones of it is x is still my true blue variable. Y happens to be a part of it that works this thing out. And x times 4y is 4xy plus 2xy is 6xy. It all cleans up. So when we have these things, just really pay attention to the first variable. Add the second variable in as the mix for the other part. I'm just going to kind of ignore it until then. But standard form allows me to see this as the quadratic term, the linear term, and the constant term, where y is just in the way. R squared plus 7rs plus 12s squared. We're in standard form. And it looks like we stay in standard form for all these. We're in standard form. R is my true blue variable. Let's go ahead and factor that guy. R times R. All positive things. I need 2 numbers that multiply to 12 and add to 7. That's 3 and 4. So R plus 3 times R plus 4. But we got to throw some s's into the mix to make sure this gets an s squared and that gets an rs along the way. That's the factorization. Number 50. A squared plus 11ab minus 26b squared. Hopefully you're seeing why standard form is so important for these. If they weren't in this form, you don't have the things you're looking for as the things that they become and represent, especially when I FOIL it out. Okay, so here it's an a times a thing. We've seen the 11 and 26 before, but the 26 wasn't negative, was it? I don't know. 13 and 2, right? There's some form of 13 and 2 that's going to come in the mix. 1 positive, 1 negative. Looks like 13 is positive and 2 is negative because of the positive sum. I got a B. I got a B. Right there. That ends up being the factored form of this guy. Again, I'm kind of throwing them in at the end or at the beginning, but I'm not really thinking about them in my calculation. They's not involved because of what they ultimately do once they are thrown in. X squared minus 2xy minus 35y squared. So this becomes an x and x proposition. And look, I can throw the y's right now. That's fine. There's a y and y proposition. What 2 numbers multiply to 35 and add to 2? Negative 35 and add to negative 2. Negative product, negative sum. 1 positive, 1 negative. The negative number bigger. 35 is 35 times 1 or 7 times 5? 7 and 5. Negative 7 plus 5. So negative 7y plus 5y, like that. That's it. All right, that was the end of it, guys. That ought to do it for this one. hit the 1 hour, 40-minute mark about. That ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. If you check the description section down below, you'll find the timestamps of these, plus a PDF and a playlist for all the IM2 stuff. Moving forward, we are going to be factoring in more complex ways than just what you saw here. I don't know how much I'm going to be able to follow the book with what it has, because I have a mental factoring version of what we do, which I can display for you guys, and I hope it's somewhat equivalent and we can cover some things along the way. So guys, thank you so much for watching. Take care, and I will see you in the next one.